Set. Good afternoon or good morning on the West Coast. This is Zach Zaharowitz of the Applications Group here at the Lighting Quotient. I'm with Paul Ford, our VP of Product Design. And today we'll be presenting the new outdoor style S175 and its indoor cousin, the S134. Before we start, you can certainly move the little box that has the two of us in it around your screen or close it. However, at the end of the presentation, we'll stop sharing the PowerPoint and we'll be on the camera to show you a few of the sample parts of the S175. Also, if you have any questions, Zoom has two functions. One is a live chat, which we typically don't use during these presentations, but the other is a Q&A box. So if you access that through the bar or the menu on Zoom, feel free to type in any questions you may think of during the presentation, and then at the end of the PowerPoint, we'll try and get to those if possible. So with that, I'm going to turn things over to Paul to start the presentation.
All right, thanks, Zach. As Zach said, my name is Paul Ford. I'm the VP of Product Design here at the Lighting Quotient. And today we're going to go over the new S175 outdoor linear LED and its indoor cohort, the S134. So I'll start off showing you the cell sheet, which is available online on our website right now. The front has a application photo with detail of the product itself, and on the back there are additional images showing a ray trace, candela curve, an exploded view of the new splice compartment, and features and benefits. And I'll take you through the features and benefits now. It is an outdoor high-performance architectural linear LED with an asymmetric distribution, has a very small profile with an integral driver. We do have proprietary optics that differ from the previous generation. I'll get into more detail in a minute. The optical control is such that all the light that does get out of the luminaire will arrive on the target surface, so there'll be minimal spill light or glare. The housing itself is an extruded aluminum, and we can do lengths up to 4 feet. We can also do lengths really up to 8 feet, but it will depend on the suspension system, whether it's cantilevered and how long you need to cantilever. So give us a call and we'll go through the details. But we can do lengths typically up to 8 feet. We do have a new mounting hub, and I will show that in greater detail, which facilitates wiring and especially through wiring. The mounting hubs have, as always, will have fully adjustable aiming and lockable aiming as well. And we do have an optional visor for use with uplighting applications. It's surface, pendant, or cantilever mounted in a choice of 2700 through 4000 Kelvin. 80 CRI is our standard, but we can get other CCT and CRI combinations. They are available upon request. There may be minimum runs that are required, but they are available. The new unit has a much higher efficacy, up to 99 lumens per watt at 4000 Kelvin, driven at 175 milliamp. At 3000 Kelvin, 700 milliamp, it's 91 lumens per watt. So the delivered lumens can be as high as 1319 per foot, and that's at 700 milliamp. We have excellent lumen maintenance for the mid-power LEDs. We're maintaining over 85% of the initial light output beyond 60,000 hours. We do have universal voltage input drivers, 120 through 277, and also 347 volt drivers for Canada. It's an all aluminum stainless steel construction, conforms to 1,000-hour salt spray. It is CSA certified and suitable for wet locations. IP66 testing is underway, so we'll update you on the website after that's through. We do have US and foreign patents pending. Now, if we dig a little deeper into the new optics, in the end of last year, we introduced the S112 linear, which had very similar optics. Rather than a molded acrylic fractor that we had been using, we're going to a continuously extruded optic, which transforms the light into an asymmetric distribution, much in the way the fractor did, but it's doing it in a more efficient manner. The cross-section you see here shows the extruded aluminum body in red. You have the serviceable light engine, so that light engine is removable for servicing or for future upgrade. It's also your access if you need to ever service the driver. in the future. What we're looking at here is a candela plot from Photopia, which is what we use to design our optics. And it shows a very nice asymmetric distribution. This is showing a single 3-foot fixture illuminating a 20-foot wide by 12-foot high wall in the center. So it's showing the coverage that you're getting from a single 3-foot fixture. And just zooming in on the optics itself, and just to give a sense of scale, that is the size of a quarter. So the scale of the optics is still very small. So looking at the fixture, you're probably wondering what is different about this than the 171 or the 132 that you're already familiar with. We typically don't like to change style numbers if we don't have to, but the 175 and the 134 required going from the high power LEDs in that arrangement to the mid power. We actually ended up growing the fixture a little bit, so it was just enough that we had to give it a new catalog number just so it wouldn't be confusing for any previous specifications that are out there. When you compare the two side by side, the cross section of the 171 has a very similar construction, has an extruded aluminum light engine with fracture optics and the driver behind it. The new light engine has a little bit of an offset to it, and it accommodates the extruded optics. So the major difference is with the LEDs going from high power to mid power, and the optics going from individual fractures to a continuous extruded optic. Now, side by side by the numbers, looking at a typical 3-foot fixture driven at 700 milliamp, we're looking at 3,500 Kelvin LEDs. Lumens per foot jumped up 15%. The watts per foot were actually lower by 32%, and the efficacy went from 53 lumens per watt up to 91 lumens per watt. So it's a 72% jump in efficacy, and that's at 3,500K. So it even gets better at some of the at 4,000. So we still have the fully adjustable lockable aiming hubs. The lens appearance is now a much more uniform appearance, and I'll show you in a bit the difference between what the fracture lens looked like and the new lens. It offers now a simple through wiring where the S171 you would have to run wiring back to the wall, out to the hub, back down to the wall if you're doing a continuous row. So it was a little harder to do the wiring. This new splice hub allows you to daisy chain right down the line. We still have serviceable light engines and serviceable drivers, and best of all, the price is about 15% lower. And all of this applies to both the 175 as well as the 134 as far as performance and the price as well. So when you look at this is just a small photo of one of the 171 outdoor, and you can see the individual light bars of the fracture inside through the lens. The new lens is a much more uniform appearance going forward. So now I'll just take you through the catalog pages. We do have one page dedicated for lighting the vertical, in this case for lighting upward or downward on a vertical. The other page is dedicated for uplighting with a visor, so uplighting across a horizontal plane like a ceiling or a canopy. On the back of the page, we have the source and style number, S175. The length and light output has been simplified quite a bit. We used to have many more choices, and some were redundant. So now we have 2-foot, 3-foot, and 4-foot in 175 milliamp, 350, and 700 milliamp. And if you click on the link, it will open up a scale performance table, and now you can look at not only all the different lengths, all the different drive currents, but also the different color temperatures and how that affects lumens per watt, lumens per foot, total lumens out, the efficacy. So all of that information is accessed directly from the data sheet, which is very convenient. Mounting, we still have the H mounting, which signifies hub mounting, shown here. This is the new splice hub. So it's very similar in size to the previous hub. We just have an area now that we can do daisy chain splicing through. Finish codes are the same as before for outdoor fixtures, and we offer all of the RAL colors And if you have a special color that you need us to match, send in a chip and we'll have it computer matched. Voltage driver options, 120 through 277, and dimming and non-dimming. We also have 347. And if you click on the MA1303 link, it'll open up all of the driver information. And it actually shows the driver information at the top and remote distances, which really doesn't apply to this product, but this is one place that you can go to get all the driver information, whether it's integral or remote. And then you can drill down and actually open up a specific data sheet for a driver itself. In this case, it's a ELDO-LED solo drive, 50 watt. For options, we have a cutoff visor, which is typically used when it's uplighting across the ceiling to prevent viewing into the lens itself. Destination requirement code is 0 for US and J for Canada. They're both CSA certified for wet locations for Canada and US. The only difference really is some of the labeling for Canada has both English and French. That's really the main difference. Color temperature, we have, as I said before, 2700 through 4000 Kelvin. And don't be afraid to ask for other color temperatures, CRIs, they are available. Dimming options, we have 0 to 10 down to 5%. Some of them actually do go down to 1%. The LightTech driver is an ELV driver, so it dims on, it only dims to 10%, but it only requires two wires for dimming on the line voltage. We have 3 different types of Lutron dimming, and we have ELDO-LED dimming. So it may not come up that much for outdoor, but this is also applies to the S134 indoor as well. The outdoor hub hangers, we used to have the HD series, now we've gone to the HF. And one of the big differences between the previous hub and what we're using now with the splice hub, it's really always an intermediate splice hub. So it's the same hub everywhere, whether you use it on the end or in the intermediate. And then at the end, we just provide an end of row kit. So if it's a single fixture, you get 2 end caps and you cap off the ends of the fixture. So this has made all the ordering for the hangers much easier, much more simple. So we have a HFA, is a surface hanger with a short stem, and an HFC, which could be cantilever or pendant. And depending on how you're using it, if it's horizontal off the wall, it's limited to 24 inches. If it's from the ceiling, it's 60 inches. And then we also have an HOJ, which is the hub only, if you want to use your own half-inch rigid conduit. And then the HFE is the end of row kit. So this is showing a detail of the hub splice kit, showing the cover. It has a silicone gasketed cover. The end cap is sealed with an O-ring at both sides, and this really just makes it easier to do through wiring down the row. And as always, it's fully adjustable and lockable at 80. We also offer a splice box option, so if you can't recess a J-box in the wall and you need to run surface conduit, the junction box has 5 conduit entries, which makes it easy to come in from any direction or go in and out if you need to. This is a photo of our rain chamber here in our test lab. This is actually showing an 8-foot fixture with 2 4-foot doors. So it is possible to do longer than 4-foot lengths, as I mentioned before, and it meets all the requirements for wet location. And as I mentioned, we are also going to be sending it out for IP66 testing. So at this point, I'm going to hand it over to Zach, and he's going to take you through the website.
All of the information, both the 175 and S134, is on the website now. I just wanted to point out where some of that information lives, as well as a couple of new things we've added under the products button. The first of those being the that to this cross-reference. And what this is meant to serve as a reference between traditional fluorescent or metal halide or even halogen elliptipar products and the new LED products. This may be useful to you if you're either thinking of something you used to use in the past and what you would use in its place now, or we sometimes get calls about jobs that were installed 10 or 15 years ago where someone's saying, do you have a similar fixture that I could go with that's an LED fixture? So this is just meant to be a really quick reference. In this case, I've highlighted one simple example relative to today's discussion, whereas we used to have linear fluorescent units, two of them, a remote ballast F151 and an integral ballast F164. Both of those would now point you toward the S175 as the logical substitute in LED. The other new link is something we're calling a quick guide. It's a very pictorial or graphic overview of all the products. And it really gives you two quick options. One is to get either directly to the PDF data sheets, or the other is to hop into our quick finder. So just focusing on the outdoor products with the S175 now taking the place of the S171. If you were to select that PDF button, you're going to get the same black and white cut sheets that Paul showed you earlier. Conversely, if you pick that quick guide, you're going to go into that portion of the site. The style number will automatically have been entered into that entry cell, and then anything that is available in terms of cut sheets and other information is automatically going to pop up over on the right. The other way to get to the quick finder is naturally to go to that square and select quick finder, in which case you'll have to type in S175 or S134, and then as shown on that earlier slide, all the available cut sheets and other backup information will present themselves. Just focusing in here on a snippet or that icon photo of the S175 uplighting, I'd like to just take you through as a reminder of what's available in each of these 6 major buckets. The data sheet is probably the most obvious. If you have looked at the photo of the uplight and select data sheet, you're going to get that version of the cut sheet that shows the visor for uplighting rather than the outdoor wall washer for lighting a vertical surface. There are really 3 main items under product fact sheets. The first would be the color cell sheet that Paul also already went through, so we're not going to cover that in detail now. But if somebody's interested in that version of the information, it's available. The scaled performance table also resides here as a link, so that even though you can get to this information directly from the link Paul showed you on the cut sheet, if someone happens to end up here first, the information is also posted here. And then finally, the TM30 color reports, which are a series of 4 zip files for each of the 4 major color temperatures we're offering as standard. And we've covered some of this information in our last few product launches, so we're not going to go into a lot of detail, but just to let you know that the spreadsheet that IES created to take the color data and generate the TM30 reports has 2 formats. We've put them both together into one long PDF, so there's some repetition. Some of the main points of TM30 compared to the traditional color rendering index: more color samples. In this case, you're seeing what look like 16 samples. They're actually meant as representations of 99 colors in total. The upper bar charts are meant kind of like CRI to show you what's the fidelity for each of these 16 color groupings on a scale of 1 to 100, essentially. The lower bar charts are meant to give you a quick indication of whether or not certain colors would be oversaturated or undersaturated. So a color bar that goes above the horizontal line is being more saturated. Those that creep below the line are being less saturated. And off to the right, this circular diagram is trying to tell you the same information. Where colors creep inside the circle, they're being less saturated. Where they creep outside of the circle, they're being more saturated by this particular LED source. There are pages that give you the new fidelity metric and gamut, which is again a measure of oversaturation, undersaturation. The traditional CRI by the CIE method also appears here. By sheer coincidence, they're the same in this example. Frequently, they do differ. You have your CIE color diagram, the spectral or radiance plots across the entire visible spectrum for both the reference source and test source. This is an interesting chart of all the 99 tested colors, and each of the cells represented here is actually split in half, where the left half is meant to portray how the reference source of this color temperature, in this case 3000 K, would render each of these colors, and the right half of each cell is showing you how the tested LED source would render that same color. And here are the total 99 colors that are used as part of the evaluation of TM30. Moving on to the ITL files, which, since these aren't all being done by ITL any longer, or more accurately, LM79 photometric reports. Paul's going to go through the more hardcore photometric data in a minute. I just wanted to point out that that same report does include the color information that feeds into the TM30 spreadsheet. So that's where the information originally comes from. For the IES files, we have a zip file that contains C format IES files, meaning these have been oriented relative to the real world. In this case, we're looking at the uplighting version of the S175. So each of these files will have been oriented in that orientation. If you went to lighting the vertical first, they would be oriented as downward wall washers. Once you open the zip file, you're presented with the three major standard lengths, 2, 3, and 4 foot. The three drive currents we're offering as standard, and then each of the 4 color temperatures. So all this information has already been factored. If you have a designer who needs 27K in the medium 350 drive current, there's no need to open one file, go to that scaled performance table, and figure out what the multiplier should be. All that work's been done in Photometric Toolbox. If you have a client who really wants to know what was the original file, they can look at the header information in the IS file, and it will say this report has been factored from which original test. So just hopefully making people's lives easier when they take this information into AGI or some of the other programs. The CAD file link will have a zip where you have two kinds of information. There are Revit files that are face-based objects that are intended to work easily with the designer using either the architectural package or the MEP package of Revit. There are also 2D AutoCAD DWG files. So if you have a designer who just wants to do a quick detail to put into a drawing set, that information is also available rather than trying to interpret it off the catalog cut sheet. The installation files cover several topics. Sometimes these are of as much interest to the designers as the installers. The general overview page covers general mounting and wiring information. One big point Paul already mentioned in using the term daisy chain. The goal with the 175 and also the 134 indoor is that the installer never has to open it. In 99% of the installations, there are always some quirky ones where we might suggest splicing inside, which you can do, but rather than taking the door frame off and removing the light engine to get at the driver compartment, the gist of the new design with the splice hub is every fixture ships with leads sticking out both ends. If you have a single fixture on a single sign, wire it at either end, cap the unused leads at the other, never open the fixture. If you're doing a row of 2 fixtures, as in this installation sheet, feed it at either end or in the center if you choose to. And then daisy chain, if you're feeding at the left end of the row, your center support's used to link the wiring together from 2 adjacent fixtures, and at the far end, you cap them and you're done. There's a sheet dedicated a little more specifically to the splice hub. This is a sheet that concentrates on that cap splice box, so if you need to do that surface conduit feed to get a row started, there's a sheet dedicated showing more detail to the splice box. Mounting centers are covered on the sheet. This would be applicable both to surface hangers, or I shouldn't say both, surface hangers, cantilevers, and pendants have the same mounting centers. This focuses on that end cap. As Paul pointed out, the splice hub is now one part. Whether you're at the middle of a row or at the end, it's really the same item. And what's different now is for each, either an individual fixture by itself or a row, is you need 2 end caps to plug the first and last hole in the first and last hub. Paul already showed you the sheet with the driver information. We also posted under installation information, realizing some people might go there first to find driver information. And finally, from this group, a disassembly sheet. This is really geared toward the idea of any user, specifier, owner wanting to know what the materials are, where might they go at end of life, and there's even a link included here that takes you to a map that would help somebody search out recycling centers in their area that might be able to receive these materials. The Configure It button is a great tool for creating customized cut sheets. We're looking at the generic version. Anyone going on the website would see this. As agents, if you go and use your rep login and enter the agency portal, you'd also see a screen like this, except there's an additional right-hand column showing you the pricing that's associated with each of the major selections as you go through assembly of a catalog number. So somebody going through this process, selecting their fixture length, drive current, and so on, would ultimately exhaust all those choices. Your last option at the bottom there are notes. So if you have some project-specific notes you want to enter, that gives you a simple text box. Once completing that, you click Cut Sheet. Your final prompt will be, do you want to enter a project name and type designation? If this is really to do a custom cut sheet, you probably do. If you're just doing something quick for someone with a general question, you might just blow by that and leave it blank. You click Generate Cut Sheet. And then what comes up is a facsimile of the standard cut sheet. A lot of the generic spec information goes away, and in its place, you get the number you created with the project name and type designation you entered, as well as a description that appears underneath there, including those special notes that you may have entered. And on the back side of that sheet, the same information will replicate at the top, type designation and complete catalog number. Just to give some love to the 134, this information is posted. If you went to Quick Finder and typed in S134, it is there. You will see information for wall-mounted uplights with visors, ceiling-mounted wall washers, and the cantilever or pendant wall washers. In this case, the photo happens to show the cantilever, but if you go through the data sheets, there are links to those indoor mounting accessories, which, if there's one point of differentiation from the 175, it is that the indoor mounting hangers do give you some different options. For instance, we have swivel pendants indoors. We typically don't use outdoors when the wind is blowing. With that, I'm going to turn it back to Paul, who's going to go through some of the testing information behind the new products. I'll then wrap up with some comments on applications, and then finally we'll show you some of the sample parts.
Okay, if we open up the cross-section again, just taking another look at it, the LED is surrounded by the extruded optic. It channels the light into an asymmetric distribution shown here. Now we usually take all of our fixtures and send them to an independent test lab, such as ITL, or in this case, we send it to UL, and they did an LM79 photometric testing. This was a 3-foot fixture driven at 700 milliamp. On the page, this is all accessible on the website right now if you want to review it. It opens up. The second page will give you dimensions of the luminaire, and as well as the measurements for color, wattage, all the electrical, the CCT, the CRI, all of that information. The third page is kind of nice. It shows graphically where the where the color points fall on the CIE diagram, and they'll zoom in on the right-hand side. You can see they've plotted this 3519 Kelvin here, as well as the chromaticity coordinates. So you can see how close it is to the black body curve, which would be the white light, representing white light. And DUV is the measurement away from that curve. So you can see it's very close, 0.0009. So it's effectively on the black body curve. Other information you'll see here again is the CRI. It gives you R9 values, as well as chromaticity coordinates for both the 1932 and 1976 diagrams and the spectral power curve. We also have a candela curve. In this case, it's aimed a little bit lower. That's how they actually tested it when in the position it was tested. But when you bring it into AGI, if you're doing any calculations, of course, you can aim it any way that you would like. And the last page has the candela tabulation. So this all represents the photometric and electrical of the luminaire itself. Next, we'll look at the chip itself. We are using an AGIA 757 GV2 chip, and the LM80 data is where they would take about, in this case, 25 samples, and they'll operate them for 10,000 hours, minimum of 6,000, but in this case, they ran it all the way out to 10,000 hours. And they'll measure at every 1,000-hour increment. They'll measure the light output, the forward voltage, and the color. In this case, we're looking at the light output over the 10,000-hour period, and you can see it only decays to 97.7% after that duration. So by knowing the LM80 data, the performance data of the chip, going back to the fixture itself, how do we relate that? We'll do an ISTMT, which stands for In Situ Temperature Measurement Test. They will attach thermocouples to the LED board at the hottest LED, as well as the driver. And by measuring the hottest LED, in this case it was 45C, we can relate it back to the LM80 data by using the TM21 spreadsheet, which you can get from the Energy Star website. So the spreadsheet, you would load in all of the LM80 data from the chip manufacturer, and then you'd load in the in situ temperature test from the third party. In this case, it was 45 Celsius. And now you can decide whether you want to project how long will it take to reach 70% if you're interested in L70, or in our case, we're looking at 85%. How many hours will it take to reach 85% of its initial light output? And in this case, it's 63,000 hours. So in short form, it's written L85 at 10K is greater than 60,000 hours, or in English, it maintains 85% of its initial light output for over 60,000 hours. Now I'm going to pass it back to Zach, and he's going to go over some exciting applications.
All right, so we're already at a half hour, but there are just a few slides here on applications before we show you the sample parts. Since we're just announcing these products this week, we don't have live shots of 175s and S134. So you're going to be seeing photos of S171s and S132s, the products that they're essentially replacing. One of the popular applications for the linear 171, now 175, has always been signage. And unfortunately, a lot of these installations are 1 or 2, 3 fixtures. We often don't get professional photography. That's again the case here. These cell phone shots come to us by virtue of our local agent and the installer in Los Angeles. But you have a target area here that was essentially just shy of 8 feet high and about 15 feet wide. The architect was originally looking at a pair of fixtures, but because of the width of the lettering and the overall backdrop, ultimately opted for 3 4-footers. One thing we didn't really point out earlier in the presentation, you can specify the 175 with so-called hubs only, and use your own half-inch rigid conduit. That doesn't seem to come up a lot. Most people have the other concern, like, could I get all the hangers from you so everything is powder painted the same exact color? In this case, for reasons we won't go into, the installer just wanted to provide their own half-inch rigid supports, which they did, and that was done by using that hubs-only specification mechanism. The bottom center photo gives you another hint of what Paul touched on earlier, that with those individual fractor optics that we had been using, even with the secondary holographic film that enhanced spread along the length of the fixture, there were still these hints of individual areas of light, so that if you would get somebody in a viewing position inboard where they could see into the lens of the fixture, some people just didn't care for that discontinuous appearance. So once again, that's something that goes away with the new 175. Another example of signage lighting, more in a landscape type setting. Unfortunately, don't have a nighttime shot to correspond to this, but this is a shopping center out in British Columbia where they had several of these side elements, some much larger, some smaller, some actually sweeping over longer arc length and bending or curving. So they came up with the thought of, rather than mounting rows where you would tend to share a hub, to allow them to deal with some of these that might not be just flat or straight, they used a consistent detail where any sign requiring more than a single fixture used all separate mounting with 2 J boxes landing on the same concrete pad, and that gave them the play to adjust the exact angle of the fixtures. You can see from this photo what they ultimately did was a little bit different than what was on the submittal drawing, but the key here was they used our cast splice box on a short bump up just to keep the fixtures some modest distance above grade, either for light snow accumulation or just to keep it out of wet dirt and mulch on a day-to-day basis. Although a lot of the applications that come in are sign lighting, this goes to show you can do facade lighting with the higher lumen packages, and you can tackle larger surfaces if you have the lumen package and the setback distance. There were some unique features about this succotash job that allowed us to provide unusually long mod cantilever lengths, but you're looking at a 40-foot row from that ledge lighting roughly the same distance, 40 feet down to the sidewalk. So with 2 neighboring buildings that weren't presenting a lot of competition, a nice light facade color in limestone, and the higher lumen package, yes, this linear unit would even be able to tackle something of this 40-foot scale if you give it enough setback distance. Moving to uplighting, this is kind of an unusual application. It's a building in the Dallas area that sits up on stilts. There was a desire to get some light onto this horizontal overhead surface so that the entire area would glow and read in that reflecting pond at night. The target surface is a little bit glossier than we'd normally like to have. The setback is way more generous than we normally get because everything's mounted on this horizontal band 1 story down from the target. But just to show one of those orientations that does come up for lighting overhead canopies. One other point to make here would involve custom mounting. The top center photo is a dry run of mounting 3 fixtures in 1 bay just to get down the logistics of it. The difficulty or the challenge here was we were told they needed to mount all the mounting plates and hubs before the fixtures went up. They wanted to mount the mounting points and then come in with these white cladding panels that would leave a reveal joint and then put the fixtures up. And in a typical installation, it's hanger, fixture, and you keep building the row. So we had to come up with a detail that had just essentially 1 fixed feed point, and then these other supports that really didn't need to convey power were temporarily movable left or right so that you could jockey them to get a fixture in place once the cladding panels were up. All this is to say is if you find yourself looking at a project and thinking, this would be a great fixture, but I don't know how the heck I'm going to get it mounted here, reach out to us and our customs group can look at it and there may be a solution. Whoops, what did we do here?
You went home.
I guess I went home. Okay, let's do Control N, it'll be quicker.
You just go up a couple.
Pretend you're not seeing these. Moving indoors, the 134. This is the Curie Dinosaur Museum in Alberta. And this would be indicative, and it is an S132 project, but this would be where you might look at using the S134. Along with all the dinosaur displays, they had several of these super graphics. Some of these, in fact, in all cases, there were rows of at least 3 fixtures. We actually provided these units with an external cross baffle, partly for shielding reasons, because you do walk around some corners and look into these. But the main reason it was asked for was, in situations like this, they wanted to limit the lateral spread that we normally have to minimize light that fell on the raw concrete bookends. So what that meant in terms of fixture appearance, if you look at the right-hand shot, especially with that cross baffle, having the fracture optics intermittently sort of gave you the sense of light, dark, light, dark. Once again, with the new continuous optics, that would have a much more uniform look over its entire length. Mounting-wise, often we get these indoor situations where we need to borrow some of the outdoor hardware, and that is doable. In this case, they wanted to mount off the top of the wall, so you essentially have the indoor cantilever here married to the outdoor splice box to allow that to happen. Likewise, here's an uplighting application using the 132, or now the S134. They wanted to have a 2-foot unit and then a mounting that wrapped these existing timber columns. There were requests here we don't have the time to go into. Suffice to say, we were able to give them an indoor unit married to some of the outdoor hardware to meet their needs in terms of surface wiring and how that needed to be managed. Finally, generically in terms of applications, if you hit that resources button and see the application square, it takes you to a page where you can pick indoor or outdoor guidelines, and you get these generic representations of what we usually recommend for setback and spacing. Many of you have heard us say over the years, if you're lighting a surface of a certain dimension, we need about 1/4 of that distance as a setback. That typically applies to the point sources. If you are going to do a continuous run, and by that I mean not 1 4-footer centered on an 8-foot wall, but a row of 8, 12, 16 lineal feet, you can look at using about half as much setback distance because that linear solution is different. Once again, as we often do, we have little caveats we throw in. In this case, we say, but not less than 12 to 18 inches. Why? These are still asymmetric optics. They're not grazers. They don't want to have their nose touching the target surface. So 12 is typically, if you're going to light, say 8, 9, 10 feet, you still need at least a 12-inch setback. 18, if you're using the higher lumen packages, it's not that what comes out of the optic behaves differently. There's just a threshold at which it seems kind of bright. So for the higher lumen packages, we try to encourage people to be at least 18 inches away from the target. Likewise, here's a page geared toward the outdoor applications, just a representation of that same information. Finally, Paul mentioned this earlier. I just wanted to touch on it again. This was stolen from an S171 catalog page. Looking at just 4-footers, you would have looked at this and said, well, I've got 4 feet, but they let me pick 24 or 42 LEDs, 2 drive currents. So I have sort of 4 lumen packages here for a selected color temperature. And in fact, the 2 middle choices were essentially redundant with each other. So just to drive home that point, the 175 simplifies that. You have a length, you pick your color temperature, you have 3 drive currents, you essentially have 3 lumen packages to choose from for that color temperature. So that concludes the PowerPoint. If you can hang in with us another minute, we'll stop sharing. You want to do the honors of that? We're going to stop sharing the PowerPoint and just get in front of the camera with some of the parts.
All right, just to show the S171 and 132 typically use a 1-foot LED board with high power LEDs and a fracture centered over each set of high power LEDs. Moving forward, we're going to use a mid power LED board, which I think you can see in there. That's a 1-foot board, and it has 36 mid power LEDs pretty much in a continuous row. And then we have the extruded optic over that, which is shaping the light. But again, it's still a removable light engine, which tucks right into the same extruded housing. You can see where it hinges right here. So it's released up at this end, and it hinges forward. It's kind of hard to see, but there is actually a driver in there. It takes up most of the space that's available. So that is the cross section for the new unit. The hub itself is a heavy gauge, thick wall, die cast aluminum. Showing there's a groove on both sides. This one actually has the O-ring pressed in using silicone O-rings. The cover has a die cut silicone gasket. So it allows you to open the cover, do your slices, replace the cover. It has a 1/2-inch threaded end on it, so that if you do choose to use your own 1/2-inch rigid conduit, it's compatible with that. The unit itself, this was shown at Education a couple weeks ago, and you can see the continuous nature of the optic now. It goes the entire length. This is not an option for outdoor. It was just a dimmer we put on so we wouldn't blind people at the show. But there's your a 3-foot 175 unit. So are there any questions on the Q&A?
If we trust the box, I believe not. Oh, yeah, it appears there's nothing in the question box. One point I'll add to what Paul said about the hub. That hub can face either direction. So whether it's a matter of wanting to choose one or the other of the aesthetics of not even seeing the cover, or just knowing in the installation it's going to be far easier to get at in one direction than the other, it can face up or downwardly. It doesn't matter. If you think of any other questions after the presentation, feel free to reach out to either of us. Paul's email is pford@thelightingquotient.com, and mine is Zach, Z-A-C-H, @thelightingquotient.com. Thanks again for attending the webinar this afternoon. We hope you find plenty of uses for the 175 and 134. Thanks again.
Thank you.
Now we have a question.
Oh, we do?
Yeah.
Oh, we got a question.
What is the ideal setback? 12 or 18 inches. For the, especially for 20-foot ceiling mounted 10 feet. For that, sure, I would say 12 or 18 works fine. I'd like to see 18. You'll just see more uniformity. If somebody objects to coming out 18 inches, 12 is fine. Facing up, yeah. 12 will work. 18 will appear more uniform. There's absolutely no reason to go out 24 inches, though. All right.
All right, thank you. Thank you.